Hello. In this video lesson, we're going to take a look at the practice for skills practice 11.2, power. Remember to have your calculator handy and nearby, and make sure you practice independently. Make sure you also pause or rewind the video as needed. Let's begin. Read along with me, please. In science, work is defined as the force needed to move an object a certain distance. And so you might remember the equation for work was force times distance. Suppose that you and a friend needed to move two 500 Newton piles of potting soil to a garden that was 100 meters away. You accomplished this task in 10 minutes while your friend took 30. Both of you did the same amount of force times distance, same amount of work, but you did it in a shorter amount of time. The amount of work done per unit time is called power. This is an example. In this example, you had more power than your friend. This skill sheet will give you the practice in how to calculate power. Okay, let's take a look at the example so far. Both you and your friend pushed with 500 newtons for 100 meters and did 50,000 joules of work. Same force applies over the same distance. However, you did yours in less time. So the first thing we need to do is make sure we convert the time to a proper unit of seconds. So to do that, 10 minutes, the time you did it, multiply 10 times the conversion factor of 60 over 1. And we do this so that the unit of minutes can cancel, and we can see it took you 600 seconds. Multiply 30 minutes by the same 60 seconds over 1 minute to cancel minutes, and 30 times 60 is 1800 seconds. So to find the power, we take the work that both you and your friend did, and you did 50,000 joules of work, and you did this in 600 seconds, which means you did 83.3 watts of power. You basically performed 83.3 joules of work every single second. Your friend, on the other hand, did the same amount of work, but in 3 times longer. And you can see their power is 3 times less than yours. So while it took you 83.3 joules of work for every second, it took them 27.8 joules per every second. You can see the same amount of work is done in less time produces more power. You should be familiar with the word watt from a light bulb, now that you see why a 100 watt bulb is more powerful than a 40 watt bulb. Now it's time to practice solving problems involving work and power. Before we do, let's visit our equation. Number 1, work is equal to force times distance. We need that. Number 2, power is the rate at which work gets done. It's work divided by time. We need this equation, and we need this equation. Now, since work is equal to force times distance, we could also write power as force times distance divided by time. You all see what I did there? I just substituted force times distance for work, and I put it right there. And then lastly, distance divided by time, well, that's speed. So I could also write this as force times the velocity. So I have 4 possible equations, well, 3 possible power equations I could use depending on the variables given in the problem. And I also do need to know how to calculate the work. Number 1 has been done for us already. 5,000 joules of work done in 20 seconds would be 5,000 divided by 20, or 250 watts of power. Let's take a look at number 2. Number 2, a machine does 1,500 joules of work, that's the work, in 30 seconds, that's the time. What's the power of this machine? We go to our box. 1,500 joules of work in 30 seconds. So this is the work, not the weight. Sometimes it's helpful to write that down because W was a variable used for weight also. So we don't want to confuse too many variables here. And we're looking for mechanical power. Since we're given work and time, we're going to use the first equation for power, which is work divided by time. Let's take our 1,500 joules of work divided by our 30 seconds. And you get 50 joules per second. But instead of writing joules per second, we're going to write 50 watts. Now you can write out the word watts, or you can just write a capital W to stand for watts. Either one is fine. Let's take a look at number 3. A sled weighing 2,000 newtons is pulled by a horse a distance of 1 kilometer or 1,000 meters. So we're given a force, we're given a distance, and apparently we're given a time, but we're given a time in minutes, so we need to change that. So 2,000 newtons, 1,000 meters, and 45 minutes. 2,000 newtons, 1,000 meters, 45 minutes. Well, that would be the force, that would be the distance, and that would be the time, but it's in the wrong unit. So we're going to multiply by 60 seconds in 1 minute so that the minutes can cancel. Multiplying that, 45 times 60, we get 2,700 seconds. So again, we're looking for mechanical power, but this time I seem to be given force, distance, and time. So it makes more sense to use this version of the equation, which has all 3 variables. Force is 2,000 newtons. Distance is 1,000 meters. Time is 2,700 seconds. Pause the video and practice this calculation yourself. If you do this right, you should come up with about 741 watts of power. And again, you can write it as a W, or you can write out the word watts. Either is correct. Let's take a look at number 4. A wagon weighing 1,800 newtons is pulled by a horse at a speed of 0.4 meters per second. What is the power? (1,800 newtons of force). Meters per second, we're given the speed. Again, you're looking for mechanical power, but this time we're going to use force times velocity. See, the version of the equation you use makes sense based upon the units and the variables given in the problem. And if you do this correct, you should get about 720 watts of power. Let's take a look at number 5. Suppose that a force of 100 newtons It's used to push an object a distance of 5 meters in 15 seconds. Find the work, find the power. So 100 newtons, 5 meters, 15 seconds. (100 newtons of force, 5 meters of distance, 15 seconds of time. Again, we're looking for power. Since I have all three of these, and I have to split it up because what I'm actually looking for is I'm kind of looking for work and power. I'm first asked to find work, then I'm asked to find power. But we need our work equation, and once we find the work, then the power is just the work divided by the time. So force times distance, let's go 100 newtons times 5 meters, and that would give us 500 joules. And now the power was going to be the work divided by the time. So let's take our 500 joules of work divided by 15 seconds. We get about 33.3 watts of power. Let's take a look at number 6. Well, a force of 100 newtons is used to move an object a distance of 15 meters with a power of 25 watts. This time we're looking for the work and the time. So 100 newtons, 15 meters, 25 watts. We're given force, distance, and power. We have to find the work done and the time it takes. That means we need our work equation. And we need the fact that the power is the rate of work done, so work divided by time. So we're going to go 100 newtons times 15 meters. Then we have 1,500 joules of work. Now to find the time, we need the power equation with time in it, and we're going to go ahead and do this thing called the switcheroo, where we end up switching out the denominator with the other side of the equal sign. The work was 1,500 joules that we just found right here, divided by 25 watts of power. And we should get about 60. Since the proper unit of time is seconds, 60 seconds.